Hey, Jim, have you ever heard of milk?
That sounds so familiar.
What about pasteurization
I have heard about that.
or homogenization?
I think I've heard of that too.
Okay, well, today we're going to talk about what it is
Okay.
and what's the difference between raw milk and pasteurized milk
Okay.
and the chemistry behind all of that.
Awesome. Okay.
Are you ready?
I'm very ready. Let's do it.
Let's do it. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Milk edition.
Milk.
Okay, we've done a few episodes on milk, but I this week had 2 different listeners reach out to me and ask about raw milk. Okay.
I can't imagine a more unappetizing word to put in front of milk.
Then raw milk.
Just like, I don't really know what it is. I have a sense of it, but I just immediately think like raw meat. I'm like, I wouldn't eat raw meat. You know what I'm saying? I know it's different.
But you'd have like raw orange juice probably.
Oh.
Right?
I don't know if I have, unless they just don't use that word because it sounds disgusting.
Yeah, it does sound disgusting.
Like simply or whatever. Is that raw? What would you call raw?
I have no idea. I don't know. I didn't look it up.
I would say fresh squeezed. Like if you go to a place where it's like, oh, they just did it. Like, yeah, that sounds good.
Yeah.
So if they said fresh squeezed milk, I'd be
Gross.
in.
I knew this was about to get weird. I should have brought up orange juice. Okay. All right. Okay.
Okay.
Before we do any of this, I want to shout out our brand new member of our community over on Patreon.
Yes.
Scott B. What up?
What's up, Scott B?
We're so excited to have you here, part of our community.
Yes.
And we're so excited to dedicate this episode to you.
Yes, very excited. Thank you for joining our community, keeping the show going, keeping the show free, getting some perks along the way. We're excited to get to know you. Thank you for joining our chem community. You too can join our chem community at patreon.com/chem4yourlife.
And Scott, be sure to check out the ad-free
feed.
RSS feed where you don't have to listen to all these ads because you're part of the in crowd now.
You're already supporting us. You know?
Okay, so let's get into these 2 different people who asked these 2 different questions.
Okay.
So Rachel E. and Anthony C. both asked about raw milk, basically like the same day. It was crazy.
Wow.
And the chemistry of pasteurization and homogenization.
Okay.
Okay, so Rachel E. said, I wonder what's up with raw milk. For one thing, I heard it doesn't spoil. Is that true?
Huh.
Also, what's the deal with the enzymes that people mention will be destroyed with pasteurization? How do they make it homogeneous? Then Anthony said, have you done an episode on pasteurization? I'm curious how it would not change the proteins in the milk it uses if it uses high enough heat to kill bacteria.
Right.
Also, does it kill viruses? And then he sent an infographic. And Jam, can we do that thing where I put my hand right here?
Yes.
And you let this infographic come up on the screen?
Yeah, I'm going to try so hard to remember that I need to do that in this one.
Okay,
yes.
and I can put this infographic in the show notes
That'd
for you.
be great.
Okay.
Yes, perfect.
Great.
Sometimes when we record a bunch in a row, I'm like, I know that there was one where Melissa did that thing. She put her hand up. And I was supposed to put there. But I'm like, but which episode and where in the episode? It helps this is also at the beginning. So,
okay.
All right.
Okay, great.
Cool.
Yes, and maybe my hand here will help. Like it can show up here. One time I saw you do it and you're like, oh yeah, I can do that. And it popped up and that was fun.
Mm-hmm.
Okay, so he sent this infographic and I can describe it for people who are listening and not watching on YouTube.
Okay.
But it basically says milk pasteurization and then it has this thermometer with a bunch of numbers next to it. And it says there's like 118 degrees, proteins begin to denature, and then low temp pasteurization, and then high temp pasteurization. And then at the top, there's ultra pasteurization. And it has some like danger. These are bad. They do bad things. And one of the things that caught my eye immediately is there's no scale. This doesn't say Fahrenheit or Celsius. It says degrees.
Yeah.
So I'm immediately like, degrees what?
Yeah, right.
The next thing that caught my eye is in ultra pasteurization, it says this kills potentially harmful bacteria in milk, but also damages all of the vitamins, minerals, and other nutrients. And I just want to say that minerals are typically salts, which don't degrade until very, very high temperatures, like in the 1,000 degrees centigrade.
Got it.
Or Celsius.
Okay.
So the minerals are not being degraded by being heated to 280 Celsius or Fahrenheit. So that immediately made me question.
Okay.
So I was immediately concerned about this infographic. So when I put it up here, we're not endorsing it. It was just the thing that was sent as part of the question.
Got it. Okay.
But I wanted to do my due diligence and go in as unbiased as possible, despite this poorly put together infographic. So I did a deep dive on what is pasteurization and how does it affect the nutrient content of milk.
Okay. Awesome.
Okay. So what do you know about pasteurization already?
I know that it was Louis Pasteur, correct?
Yeah.
He was out in his pasture one day, and that is all pretty much all I knew in the sense of like the questions have already been basically like heating up the milk he discovered killed stuff, and it was beneficial in some way to where that became a industry standard for milk, maybe other things, I don't know.
Right.
For a long time. And then a couple of years ago, I started hearing about raw milk. And my first thought was, I wonder why he had to do that if now we don't want to do it.
Yeah.
You know what I'm saying?
Mm-hmm.
Not saying there's not a good answer. I just am like, I remember learning about pasteurization as like just one of those inventions people talk about.
Yeah, that like really changes things.
Yeah, that made a difference in society or something.
Okay, great. Well, the basics are good.
Okay.
I'm actually going to go even more basic than that and talk about milk and what it is and why it goes bad in the first place.
Got it. Okay.
So if you haven't listened to our earlier episodes on milk, we go a lot more in depth. But essentially, milk is comprised of whole milk from a cow, is made up of fats, proteins, vitamins and minerals, water, and sugar, lactose.
Got it.
Okay. So you can check out our earlier episode on butter and whipped cream to hear more about it. So why does milk go bad in the first place, do you think?
I would guess that we talked about yogurt, and I think it's that. Exactly what those words were and what was happening is fuzzy.
Yeah.
But there's things living like in it that grow and change the stuff. The sugars get like eaten and changed or something, right? But yogurt was just long enough ago where I'm kind of like, yeah.
Okay. Well, here's a quick review. You're right. So there's bacteria that makes yogurt.
Nice.
And milk goes bad because this bacteria, the type and amount can vary based on the level of pasteurization or other things. But even pasteurized milk has bacteria. And bacteria can feed on the lactose and make lactic acid, which is acids are sour, so sour milk.
Okay.
Other bacteria can feed on the other nutrients like proteins and things like that. And the byproducts are going to mess with the smell and the taste. So you don't really want to drink it.
Got it.
Some bacteria can feed on the milk, which is a really good, it's a really good nutrient source. So bacteria can really thrive in milk.
Okay.
Some bacteria will eat that and produce dangerous toxins. And they can make us sick. We call those pathogenic bacteria, or they can make us sick other ways, but they can either make dangerous byproducts or they will make us sick in other ways. Okay, so let's talk about then how bacteria gets into milk in the first place.
Okay.
Some bacteria is passed from animals to humans. And if it's illness, that's called like zoonotic illness. So it'll be passed from the animal into the milk.
Okay.
Other bacteria can get into the milk as a contaminant. So that could be at any point from when it leaves the cow's udder to when it gets to your mouth.
Okay.
There can be good bacteria. So one good bacteria is the lactobacillus species, which helps us make yogurt.
Okay.
That can be in milk, or there can be the bad bacteria, the pathogenic kind that can make us sick.
Okay.
Okay, an interesting fact, though, that good bacteria, the lactobacillus species that specifically helps with yogurt, is not naturally occurring in milk. It gets in there as a contaminant.
Oh, wow.
I know.
I guess that's kind of like how I guess this a little bit, but like other things that sort of ferment or whatever, like or like dough, yeast getting in it, like those things happen to be like enough in the air for people to do that in the past. Like you didn't have to like go get yeast or something. You could, yeah. Huh.
And if you think about milk is coming from a cow, which is an animal.
Mm-hmm.
So the animal lives in a barn. There's manure, they're an animal. So even if it's a very hygienic place, it can still get contaminated any number of ways. And because milk is such a good growth medium with sugars and fats and protein, the bacteria can really proliferate in that environment.
Okay.
I'm having a hard time. I'm getting my tongue twisted today. Okay, so that's a little bit about how bacteria gets into milk.
Okay.
And how it makes milk go bad. So then what does pasteurization do? Like you said, it's a process of heating up milk to kill bacteria. And before we talk about why this works, I'm going to go into our chemistry lesson for today. It's kind of a review.
Okay.
So if you want to go more in depth on proteins, you should listen to our last week's re-release episode about eggs.
Nice.
But just to quickly review, because Jam hasn't listened to that episode back yet. We're recording out of order.
Yep.
So, oh no, my laptop's about to die.
Uh-oh.
Screen wipe. There you go. Okay, now back to your regularly scheduled programming.
We're in.
Okay. So, where was I? Oh, yes. About to do a quick review. Okay. So protein, if you remember, is a polymer. So it's a large molecule made up of a bunch of small molecules.
And those molecules are amino acids, right?
Wow. Because that's the one thing that you learned from your high school. What was her name? Miss Pittard?
Miss Pittard was chemistry, but I want to say we talked about this more in biology at the time.
Okay.
Like, I know it's both, but yeah.
Okay, so amino acids are, you're right, they're like the building block, and amino acids are just little organic molecules that have certain types of functional groups, which are collections of atoms that act in a certain way.
Okay.
And they repeat over and over. My favorite analogy for this is like a necklace. I actually have a pearl necklace on today.
Nice.
It's not a string of pearls like a lot of people have, but
say
it was all pearls all the way around. Each little individual pearl would be like an amino acid, and it builds to make the big long necklace. And then if you now imagine taking that necklace and twisting it all up into a big knot. So that's what happens in a protein, is you have the protein is a strand of amino acids that are then mixed up together in a knot, and they're held together in their folded up, knotted way by...
They're held together in their folded up, knotted way by intermolecular forces?
That's right.
Okay.
So intermolecular forces are if you have two atoms or two molecules that come near each other, the forces that attract them to one another are called intermolecular forces, and they might not be as strong as a really strong attachment would be a bond. And then a really weak attachment, they'll just temporarily come into place and then sort of keep going. And then the strongest intermolecular forces are like almost bonds. We call those hydrogen bondings. They're like one step down from a bond. And that's what we have a lot of here. We have hydrogen bonding holding our folded up protein structure in place. So like imagine two beads come near each other. They have just the right functional groups on them so they can, the molecules can interact in just the right way. And if you want to learn more about intermolecular forces, you can go back to one of our very early episodes about geckos.
Yes.
And how they stick to walls. Okay, so that's what we have in our protein. We have intermolecular forces holding our necklace all tied up, our amino acid necklace all folded up.
Okay.
And it needs to be folded up in this specific way to function the way it's supposed to function. And if we break those intermolecular forces by putting energy in or by putting them in acid or anything like that, the protein will unfold into just a plain old strand instead of being folded up, and then it loses its functionality, right?
Right.
That's called, do you remember what it's called?
Loses functionality. Did we say denature already?
Denature.
I think you might have
Oh,
mentioned
did I
that
say
earlier.
that already?
Yeah, but I think I would have gotten it probably.
Okay.
But you gave me that hint.
I just got too excited.
Yeah, it's okay.
Okay. Yeah, okay.
No,
great.
I think it was actually maybe just on the... Oh, or did someone ask that? Did your brother?
Oh, maybe. Yeah, maybe.
Okay.
Anthony asked that. Yeah.
Yeah.
Okay. Okay, so that's how proteins will get denatured. They'll unfold if they're exposed to energy like heat or if you put them in acid. Okay. So now all proteins are different and they have different amino acids that make them up, which means they will have different functional groups that can interact. They have different numbers of interaction sites. So because of all that, they don't all just denature at specific times.
Okay.
So pasteurization, the scientists figured out that they could specifically target the bacteria that will hurt us, the pathogenic bacteria, the bad bacteria.
Okay.
And so after pasteurization, which is your milk heated, every molecule of milk, the whole thing has to be uniformly heated to a certain temperature for a certain time.
Okay.
Lower temperature, it has to be there longer. Higher temperature, shorter.
Okay.
Okay. And after pasteurization, a lot of the pathogenic bacteria that will hurt us, that's very commonly found in milk, will be denatured. The proteins in the bacteria will be denatured, so this cell of the bacteria can no longer make you sick.
Okay.
But that doesn't mean that there's no bacteria in it anymore.
Okay.
No bacteria at all is called sterilization.
Right. So they're just targeting the pathogenic.
Yes.
Other bacteria could still be there.
Yes.
But at least all the ones that they were targeting would probably be gone?
Yeah.
Okay. Got it.
Yes. Or
Okay.
they'd be in so small amount, I guess, that they wouldn't be able to have any appreciable negative effect.
Okay.
But I think they should all be gone.
Okay.
Because that's the industry standard, or at least they have to be below a certain barrier.
Got it.
Okay. So pasteurized milk still has some bacteria in it, not the dangerous bacteria. And that's why our pasteurized milk can still go bad. But it's very unlikely to make you sick.
Okay.
Ultra pasteurized milk is heated to a higher temperature, a much higher temperature, but it's only for like 2 seconds or something really short.
Mm-hmm.
So that has even less bacteria present, so it can last on the shelf for even longer without going bad.
Okay.
Okay, so that's what pasteurization does. It kills bacteria that might be present in milk from contamination sources, such as anything that happens between the cow and your mouth, but also anything that the cow passed into it that's dangerous.
Got it. Okay.
Okay. So that is the science lesson, is the sort of basic review of the protein, has those intermolecular forces, and heat breaks the intermolecular forces, which means the protein can't do its job because it doesn't have the perfect shape that it needs. And then that hurts all the proteins that bacteria have in them. So bacteria can't still hurt us, or those bacteria.
Yeah. Okay.
Okay. Makes sense?
Yes. Makes sense.
Okay. Do you want to try to explain that back to me? And then I'll answer the specific questions from our listeners.
Okay. Yes. So in milk, there are bacteria that are passed into it by the cows just right away. They're a living organism that has bacteria in them, just like we do. And so the fact that the milk already has some in there isn't weird.
Yeah.
But also other bacteria can find its way in. The numerous steps from just what's in the environment directly outside of the cow.
Right.
And anything in between there and here, right? And so within the bacteria are made up of proteins.
Yes.
Okay.
So usually bacteria are single-celled organisms, and they have like an encasement that might be made out of protein, and then their little organelles, which I don't know if you remember, but the tiny little things inside cells,
Oh, yes.
a lot of times made up of proteins. Yeah.
I remember that I had to. There's like so many times in biology we had to do those diagram things, like draw your own version of it, you know, and draw each little organelle.
Or like use candy to make yourself a cell.
Yes. That kind of stuff.
They drilled that into us, I guess.
And that was, I guess I didn't give her credit a second ago when you asked me about that. That was Miss Wise. So,
yeah.
Shout out Miss Wise.
Thanks, Miss Wise.
I actually took biology twice because I took it as a freshman and then took AP biology as a senior.
Nice.
I had it for both of them. So, yeah. So, me remembering that, I remember some of the stuff that you taught, Miss Wise. Good job.
Thanks, Miss Wise.
Mitochondria, endoplasmic reticulum,
Golgi
apparatus, ribosomes, yeah, all that stuff. Okay, centrioles, it's like weird
vesicles.
It's like starting to come into my brain, and I can remember like the little doodles. Okay, so the bacteria are single cell stuff. That stuff inside of them, and like probably even their like just structure is made up of proteins.
Yeah,
and so if you heat up the milk to the right temperature, if you're targeting those proteins that are in those bacteria, the heat causes what makes up the proteins is the amino acids that are tangled up together by intermolecular forces. If you add a lot of heat into that, those can't stay together in the same way that they were.
Right.
They start to fall apart.
Right.
And if we do that at the right temperature for the right amount of time, we could kill almost all of the bacteria that we were trying to kill.
Yes.
By just making them fall apart, basically.
Yep.
And that's it.
I think that's it.
Okay, sweet.
Okay, great. So,
but there could potentially still be other bacteria that's not the kind they're targeting.
Yeah, that's not likely to make us sick, but could make the milk go bad.
Right.
And so that is why we then have ultra pasteurization that will kill even that stuff. It can make the milk taste a little burnt though for ultra pasteurization, unless they do it really well.
You know what's weird though too is that like whenever I've used milk, maybe this will be something that will make sense in a little bit, depending on what else you share. When I've made like coffee milk drinks, it's possible to just even at home heat milk up in a way that makes it taste kind of weird.
Yeah.
And actually kind of eggy.
Yeah.
In reference to the re-release, but like, it's weird that we can do that, but yet it went through a process that heated it for that.
Yeah.
Kind of odd.
You have to heat it very carefully. And so a lot of the things that I read was like you have to heat it and then cool it very quickly so that it doesn't get that burnt thing. And it can be hard. So one of our references that our listeners might want to check out is from Chemistry and Engineering News. And it's an interview where someone talks to someone who's all of his research is about ice cream, which I was like, okay, I went into the wrong field.
Yeah.
I want all my research to be about ice
You're
cream.
like, I didn't think about the ice cream chemistry field.
I didn't. Bad choices. Okay, but I do want to get into specific some of the questions that our listeners asked. So, and also I guess I should start by saying that Rachel's question was about, well, you know, what's up with raw milk? And so there are proponents who think that drinking raw milk is better for you. It's more nutritious. It's there's like some pretty unfounded claims about allergies and it helping with allergies, and even some more like serious things. It could even maybe help with cancer. But there's not a lot of evidence, especially for the allergies and the cancer. There's one study that potentially indicates that those who drink raw milk have less sensitivity to allergies, but there are also people who grew up on farms.
Okay.
So there's like a lot of confounding variables there.
Yeah. Which like I guess people for a long time did just drink milk that they had just milked themselves right there.
Yes.
So maybe it only became necessary because they're trying to transport it or something.
Well, we can get into that, into the statistics. Sorry. But so that is probably why Rachel has heard some stuff about raw milk.
Okay.
But specifically, she said, I heard that raw milk, it doesn't spoil. Is that true? It is not true.
Got it.
And in fact, it spoils faster.
Right.
Because it still has all that bacteria.
Right. Okay, that would make sense. I was like, if it doesn't spoil, then like, what the heck? Like,
And what are we doing?
Yeah.
Yeah. Okay, so it can spoil even more quickly because there's more bacteria in raw milk, although some people do pasteurize it at home. And then Anthony's question about the infographic was more about if the pasteurization messes up the content of the milk, like the nutritional value.
Okay.
And here's the short answer. Some nutritional content can be impacted by exposure to heat.
Okay.
But it's not to an extent that is appreciable. So I'll talk about some of it. He specifically asked about the proteins. And, you know, if it's high enough to kill the proteins in the bacteria, isn't also going to denature the proteins in the milk. And to that, I say, yes, whey protein in milk can be impacted. It can be denatured, so they can't function in the same way. But we don't need the proteins in milk to function in a specific way in our stomach.
Got it.
The nutritional content of the proteins are still there.
Okay.
Right? Because they still have all those chains of amino acid, which is what our body gets out of those proteins anyway.
Okay.
So that shouldn't matter, even if they are denatured. It does matter a little bit for like processing plants. If they're trying to then make cheese or something, the way that the proteins interact with each other is different.
Okay.
And so that can have an effect. But for the consumers of milk, people drinking it for the nutritional content, I could not find any papers that indicated that once whey has been denatured, it loses its nutritional value.
Okay.
Including whey protein drinks. Those are also pasteurized from what I saw. So I couldn't find evidence that that would cause any problems, the whey being denatured.
Okay.
Some other things, good bacteria. Good bacteria does die. But like I said earlier, some of that good bacteria isn't even necessarily from the milk. It's contaminated.
Right.
So instead of adding it before the pasteurization process, what can happen is people will add it after the pasteurization process. And then that's how we get yogurt and cheese. So it's totally fine for us to have bad bacteria added in at a later, good bacteria. Good bacteria added in at a later stage when it's not likely to risk contaminants that will get us sick.
Okay.
So if it does kill good bacteria, that's okay because we can add it back in. We can easily isolate it and add it back.
Okay.
And we can do that in a much safer way. And people do. And I think the purists who are like, well, but it's not present in raw milk. A lot of good bacteria isn't present in raw milk anyway. It's contamination. So that's okay, I think.
Okay.
Vitamins can be impacted, but they are minimally impacted.
Okay.
They're not present in large amounts in the first place, and milk isn't considered a primary source of a lot of vitamins. Vitamin A actually increases after pasteurization. So really the only vitamin that appears to be significantly impacted and milk is a major source is vitamin B12, riboflavin, I believe. And you can get that in other sources.
Okay.
So, and one of them is almond milk. Or almonds, for example.
Okay.
So I said maybe not almond milk if it's pasteurized, I guess. But you can get riboflavin in almonds. Okay. But also I want to say that the vitamin content in milk is going to vary anyway based on what the cows are fed, the time of year, the number of milkings of the cow. And so I would say that maybe vitamins might be impacted to some extent, but it's not an appreciable amount, and it's not like they can't be made up other ways in other places. And then minerals, I already talked about. Minerals literally can't be affected, so that one's just not founded in science at all. And then fats and sugars should be temperature stable. So the main components of milk are not, the nutritional value of milk is not going to be highly impacted at all. By pasteurization. But there are risks associated with drinking raw milk. So the risks associated are primarily food poisoning, foodborne illnesses, and you can get them from many different foods, but raw milk is especially risky because I think, although it didn't say, because it's such a good medium, but also because of the environment in which you get milk. A lot of times it's just not super clean. And so that can do a lot of digestive problems, but it can also, some people who drink raw milk have developed severe or even life-threatening diseases, including Guillain-Barré syndrome, which can cause paralysis, and hemolytic uremic syndrome, which will result in kidney failure, stroke, or even death.
Dang.
Yeah, so it is really valuable. Like it's not going to necessarily happen for sure. So a lot of people who drink raw milk have no problems, but it can be bad.
I see. Okay.
And in 1938, before we had rules about pasteurization, raw milk was responsible for 25% of all foodborne outbreaks in the United States.
Wow.
After pasteurization, between 1973 and 1992, the number of raw milk originated outbreaks was only 46 or 2.5-ish a year.
Wow.
So it went way down.
Yeah.
And there is still a very small number, like I think it was 50 in the last 10 years or something. Don't quote me on that. You can look at our resources. So there's still a relatively small number. But if you think about the number of people who are drinking raw milk, that ratio is actually kind of high. So because of the nature of raw milk, it can be really dangerous.
I see. Okay.
So there's just no reason to risk those bad bacteria when pasteurization does not significantly impact.
Right.
Now, one thing that infographic did get right is the lower temperature for longer won't necessarily impact as much.
Got it.
But it still should not significantly impact your nutritional value. So all I can say is if you're someone who has raw milk, maybe just consider pasteurizing it at home. But in a lot of states, it's actually illegal to get raw milk.
Interesting.
Yeah. So there's a funny episode of the TV show Schitt's Creek about raw milk.
Oh, interesting. I've seen that show, but not all of it. So I must have missed that one.
Okay.
Yeah.
They ask for like 10 jugs, I think, and they get like 10 big like barrels or whatever. Yeah. Okay. So that's a little bit about the pasteurization and the importance of that and the risks of not participating.
Okay.
Now, before I switch to homogenization, just real quick, do you have any questions?
So we answered it does not last longer, lasts less long, spoils faster.
Yep.
Does not have a significant higher nutrition.
Right.
Does it taste different? I feel like I've heard people say that.
Yes, I think it could. Yeah,
Okay.
that's I think a matter of preference and hard to say, but I would guess that it probably does taste at least a little bit different.
Okay.
Something I wondered about was if it's heated, some of the water will evaporate, and I wonder if it's thicker. But here's a different thing that might also impact maybe like your mouthfeel.
Yeah.
Is the homogenization.
Okay. Got it.
And I think it's hard too because like raw whole milk from the cow has all the fats and stuff in it. It's not processed in all the other ways that our milk is processed, you know? So it's like we get this separated out, the 2%, the skim milk, we have heavy cream. And so I don't think if you got a milk straight from a cow, it would be a very different experience than getting a jug.
Yeah.
And even a friend of the show, Jeannette, recently told me she started drinking organic milk and it's so much thicker and creamier that the regular milk is like water.
Yeah. Huh. Interesting.
So.
Yeah. I don't just drink a lot of milk. It's just not that appealing to me. So it's kind of interesting to hear people have a lot of preferences around it where I'm kind of like, about milk? Like,
yeah, but that's how they feel. The way you feel about coffee.
Right.
How they feel about milk.
Yeah. Yeah. I can probably think of a way around that. I'm usually pretty good about thinking of a way of figuring out like, well, when I do it, it's makes sense, but when you do it, it doesn't. When I do it with coffee, it makes a lot of sense because of blah blah blah. I should figure out what those reasons are, you know.
Yeah.
So that I can be like, so I can still know that like, oh, you're weird, I'm normal.
Well, I'm
actually absolutely not normal, by the way, at all. So
I actually am also lactose intolerant. So I used to drink so much milk, but I don't
Yeah,
No,
yeah,
it
yeah.
would always upset my stomach. So, okay, so let's now. Also, friend of the show, Jeannette, talked about how the raw milk that she got in Mexico, it was chunky. So she grew up in Mexico. It was chunky. And that brings us to Rachel E.'s other question about homogenization. Okay, so homogenization is typically done with pasteurization because the milk's already hot. When things are hot, you put the energy in, they move around more. That's actually, also how the intermolecular forces break is things are moving around more, and then they will split apart. Okay, so things are moving around more. They're more malleable. You've seen things get melty when they heat up. Okay, so homogenization sends the milk that's hot also at high pressure through small holes, and that breaks up fat globules. So the fat is evenly dispersed in the milk and it doesn't separate. And we've also talked about how milk proteins have hydrophobic and hydrophilic, which go back to our cream episode for that, I think, or butter. So then it stays homogenized once they break up these big fat globules. But the raw milk would have the chunks of those in it. It wouldn't be homogenized. But you can have homogenized, not pasteurized, and you can have pasteurized, not homogenized.
They just do it. They tend to do it at a similar time when they do it, but it is not necessary. You don't have to.
Yes, and the pasteurized, non-homogenized, you can buy that at the store, and it's often referred to as cream line milk because a layer of cream with the fats will rise to the top when it stands in the refrigerator.
Got it. Man, one of those. It's crazy, man. Milk is crazy.
I know. Milk is crazy. This is like our 3rd or 4th episode about milk.
Yeah.
But I did realize I wanted to talk about that when I talked about the intermolecular forces, and I was so excited to talk about pasteurization that I forgot to talk about it. Is the reason those intermolecular forces break is when you heat things up, you put energy in.
Right.
And so the molecules start to vibrate and move, and the more and more that they're vibrating and moving, the harder and harder it is for those little electronic forces that are holding these two atoms together to stay in place. They can't overcome that energy, and eventually the energy will be too much for them and they'll break open. Yeah. Which is also what happens when things boil and when things melt.
Got it.
Which we've talked about that before too.
Yes.
But I was so excited to talk about my milk facts that I forgot to tell you about that. Okay, so do you have any other questions?
I don't think I do.
Oh, one other one that Anthony asked was, does it kill viruses? And it does. It can. Some viruses. So.
Got it. Okay. Got it.
Well, that's a little bit about milk. Normally we wrap up with a fun fact, but we had our fun fact versus fake factoid, last week. So I feel like people are getting in a lot of fun content. And so if you want to hear more about what's going on in me and Jam's lives, you can come check us out over on Community, like our new friend Scott
B. Can I offer a milk hot take potentially?
Yeah, like a category, like a milk category, milk hot takes.
Could we do that?
Okay. Yeah, let's do it.
Do you think you can come up with one too?
Oh yeah, I can. I have one immediately.
Okay, cool. So here's one I have. You know how some people don't like that things that are like almond milk or oat milk? Yeah, some people don't like that we're using the word milk with those.
Yeah.
I don't know exactly what reasons they have, but here's my hot take. We use words like milk to describe other stuff that's not milk, and we've all been fine with it. So for instance, we're eating peanut butter.
Right.
And if someone was like, hey, that's not made of butter, dude, like you cannot call it that. It's peanut spread, like that, you know? Like that would be kind of annoying. It's like, oh, it's similar enough. It's a similar consistency, and it's nice to know that you can, this is a replacement. Yeah. I could use this for this.
Yes.
It's not exactly the same thing.
Yeah.
So I always think when people are like, it's not actually milk, I'm like, but other things we do that with. Like, we do that with syrups. We do that with butters. It's like we're trying to talking about the form factor it comes in. This is in a milky form.
Yeah.
And it can be used in similar ways. You could use this one instead in your cereal. You could use this one instead in your oatmeal or whatever.
In your coffee.
Yeah, in your coffee. Some people are know with that. I'm kind of like, but you're not annoyed when we talk about it with like butter.
You're just looking for consistency.
Yeah, apple butter, peanut butter. It's like no one's getting mad about it then.
Yeah.
So all I'm saying is like you can't use the word butter anymore. Sorry.
Well, hopefully we're not making Big Milk mad right now because I just listened to an episode of Criminal Podcast.
Criminal.
All about how it's illegal to use margarine unless specifically asked for in, is it Wisconsin, I think?
Whoa,
And-
because of Big Milk?
Yeah, because of Big Milk, basically.
Wow.
Milk has its own lobbyists, and they are the reason why we can't call things like Velveeta and shells cannot be called Velveeta cheese because it's not cheese. Like they have rules of things you're not allowed to call dairy products.
Right.
And they're mad about the fact that we can call almond milk milk.
Yeah. And I do like we've talked about in other areas, like there being transparency and labeling.
Mm-hmm.
Obviously, that's a good thing for sure.
Right.
But people aren't actually confused about what they're buying when they buy almond milk.
Yeah.
But if people were, I would be like, okay, yeah, let's talk about this.
Yeah.
Like if there was grocery stores selling us something they were calling milk, but it actually wasn't like cow milk, but they never told us that. But almond milk, I know it's not cow milk.
Yeah.
Oat milk, I know it's not cow milk.
Yeah.
But yeah, if it's like sneakily something else, then I'm cool with it being like, hey, we should make some laws around like making it clear. That's like, I guess that's kind of weird, huh?
You should check it out. It's really interesting.
I will check it out. Big Milk.
Big Milk. My milk hot take is actually cheese hot take. And
Okay.
that, I don't know if it's really a hot take, but this is a hot take in my house. Blue cheese
Mm-hmm.
tastes like baby vomit smells.
I could see that.
It's a very specific memory that transports me back in time.
Mm-hmm.
Also, now that I don't drink milk, when I smell it, it smells really gross. I like it. I'm like, ugh, every time I smell it.
I'm around milk a lot because my kids drink it, and so I'm used to it, right?
Yeah.
But I don't drink it myself almost ever, really, and so I'm like kind of somewhere between. I'm with you. I'm not intolerant. I just don't drink it really. But I have stayed around it.
Yeah.
So I've had to smell it a lot or whatever. But yeah, I could say that'd be odd. Certainly is odd that we like get milk from an animal and drink it.
Oh, that should have been my hot take. Is it's weird that we steal milk from baby cows.
Yeah.
My mom got mad at me for saying that when I was younger. But it is weird.
Yeah.
Why are we stealing milk from other baby animals?
Right.
Doesn't make sense.
But at the same time, the fact that animals and humans can make milk, that's pretty fascinating and awesome.
Yeah, that is.
So,
and also that human milk and maybe animal milk is like responsive to the baby. So like if your baby's sick, you'll get more antibodies in the milk and stuff. That's crazy.
Yeah.
There's so much that's crazy about milk, and we just are barely scratching the surface.
Yeah. We're barely skimming the surface.
Skimming the top.
Yeah. Yeah.
Skimming the cream.
Yeah.
All right. Well, that's all I have. Thanks for letting me talk to you about milk. And thanks so much to Rachel and Anthony for sending your questions in. You guys were on the same wavelength.
Nice. Very cool. Yeah. How crazy. Like, what if they both happen to like see like some sort of big milk lobbying ad or something like that? And that's what happened.
I think it would have been raw milk, which is,
right.
I don't know if they're on the same team or not.
That's a good point. Yeah. Yeah. Maybe it's like not a coincidence somehow. Yeah. Thank y'all for sending those questions in. We love your questions and thoughts and stuff. Always send those to us. Something you think you're wondering, you see out in the world, you think in your everyday life, is this chemistry? And it might be. It probably is. So send that to us on our website at chemforyourlife.com. That's chemforyourlife.com to share your thoughts and ideas with us. If you'd like to help us keep our show going and contribute to cover the costs of making it, you can join our super cool Chem community of patrons like Scott B did over on patreon.com/chem. Patreon.com/chem for your life. Also /chemunity, which who knows, someone else has that URL.
Yeah.
Patreon.com/chem for your life. Join our super cool Chem community of patrons. You get exclusive stuff, ad-free version of the show. Depending on which package you pick or tier you pick or whatever, you get different perks, behind the scenes stuff. You get to learn more about us. We get to learn more about you. Most importantly, you keep the show going and keep it free for everyone else. And if you cannot do that, though, you can still help us by subscribing on your favorite podcast app, writing, review on Apple Podcasts or Spotify, subscribing to our YouTube channel, and leaving a comment over there telling us hello. Those things help us share chemistry with even more people, help us help the podcast find more people who are interested in chemistry.
This episode was made possible by our community. Thank you so much for your financial support. It's so exciting that y'all are excited about chemistry and you want to help make chemistry accessible to even more people. And those people are Scott B. What up? Welcome to the team. Jessie R., Ciara L., John T., Avishai B., Bri M., Brian K., Carol R., Chris and Claire S., Chelsea B., Derek L., Elizabeth P., Emerson W., Hunter R., Jacob T., Kristina G., Katrina H., Letila S., Lynn S., Melissa P., Nicole C., Rachel R., Sarah M., Stephen B., Suzanne P., Timothy P., Venus R., Erica B., Cullyn R., and Jeannette N. Thank you all so much for making Chemistry for Your Life happen. And an extra special thanks to Bri, who sometimes creates illustrations that go along with episodes of Chemistry for Your Life.
And if you'd like to learn more about today's chemistry lesson, you can check out the references for this episode in our show notes or in the description of the video on YouTube.
Yay, chemistry!
Yay, chemistry!
Yay, pasteurization!